Hi, I am Pawan Kumar. This is FieldWise, a multi-agent crop health advisor I built for the Kaggle AI agent Capstone project. This comes under the track Agents for Good. Now let me show you the problem it solves, how it works, and then a live demo. A farmer notices something wrong with their crop. It may be a brown spot on the leaves, or the plant looks pale and stunned. They have no easy access to an agronomist. Searching online just tells them to use a fungicide. Which crop, which fungicide, where to buy it, and how does it cost? That advice is useless without local contests, and by the time the real help arrives, the yield is already lost. I built FieldWise to close that gap. It takes a farmer's plain text description and optionally a photo and returns a specific diagnosis, real nearby suppliers with prices, and a follow up schedule. Now, let's discuss about the architecture of FieldWise. The architecture is break into specialized agents which solve this problem. Each agent has one job and its own confidence score. If the system isn't sure enough at any stage, whether it is a triage or a diagnosis stage, it stops and says this needed an human expert instead of guessing. That's not a disclaimer, that's an actual architecture. The pipeline is vision agent reads the uploaded photo, the try agent classifies the problem, diagnosis agent names the cause, and the resource agent calls an MCP tool to find the local supplier, and a follow up agent schedules a recheck and logs the case. Let me show you running this. I'll start the web app. Yeah. Here we describe the disease case. This should trigger a disease pipeline. A farmer just take a photo like this on their phone and upload it. And keeping the field ID and region the same, we click on get advice and the results show up. So here the try agent classified this as a disease. The diagnosis agent identified early blight. And here is a plain language explanation a farmer can actually understand. Then the research agent called our MPC server, a real separate tool running the model context protocol, and returned locally available treatments. Not just generic advice, actually the nearby suppliers, specific products, and the price in their rupees. And it also provides a follow-up agent scheduled and a recheck date and assigned a case ID. Here, it shows how the agent reached this result. This trace shows exactly which agent made which decision with full transparency. This project has 5 agents plus an orchestra, all in the agents folder here. Each one is a single file with a single responsibility. Now coming to the MPC server. The MPC server is a real separate process built with the official MPC Python SDK. It exposes a find a local treatment tool over the standard input output transport. I tested the actual protocol handshake, not just importing a function. Now coming to the LLM client agent, where this is an LLM abstraction layer. Right now it is running in mock mode, free, offline, no API key needed. But one environmental variable flips it to real Gemini. No agent code anywhere else needed to change. Now coming to safety and it tests. We run a simple Python command. As we run it, the test performs. Here, finally 11 tests. Importantly, these aren't just happy path tests. There are dedicated tests for safety behavior and cases where the system should correctly refuse to diagnose. All the code is on GitHub. Everything runs locally with no API key. Links in the description. Thank you.